Ni hao. Good afternoon, ladies and gentlemen. It's a privilege and an honor for us to have the opportunity that Jaco is giving us to present our company in front of this so special audience. So let me introduce you what is Prysmian, what is my company, what we are doing, what we are able to do. And what we have already done. First of all, just one only slide. I don't want to bother you with marketing information. We are a 7.5 million euro company, 82 factories all around the world, 50 presence in 50 countries. More than 140 years of history since the old Pirelli cable times and recently merging with Draca cables. All this long history supported by this focus that our company has traditionally had with R&D development. This is the world leader, with all due respect to our competitors and the local players. This is the world leader in cable manufacturing as of today. In Prysmian, there is this division which I represent, which is Prysmian Powerlink, which is focused on submarine cable business and DC transmission. We have 3 different factories specialized in cables, medium voltage cables, in Piccola, Finland, in Arco Felice, Italy, our home country. And we have our fleet of vessels, of cable installing ships, able to perform whatever different requirements for different project specifications. We are just starting the manufacturing of a new cable laying ship, which we announced a couple of weeks ago, which should be the best ever existing in the industry, to be ready in a couple of years. So, what is the technology that we choose for a submarine cable transmission, a submarine cable link? This graph that you see on the screen is showing that there is an existing barrier beyond the 100-kilometer distance of transmission. This is a physical barrier due to the losses, the properties of the electrical transmission. So this is not an exact barrier, but there is a gray area in which when we go above and beyond this length, we need to use DC transmission to make it economically viable or feasible. In the vertical axis, you can see that developments with AC extruded cables, so plastic, XLPE, cross-linked polyethylene cables. As of today, existing projects is 420 kilovolts, 500 under construction. Existing projects of AC used to be with fluid-filled cables requiring oil pumping stations. So the distance cannot be very long, around 50 kilometers. In terms of DC, you see that there is another barrier which is around 525 or 600 kV, dividing what is the maximum existing technology for extruded insulation cables, plastic insulated cables. Above the 600 kV, we can only find cables insulated with mass-impregnated or mass-impregnated PPL, polypropylene laminated cables. So in more detail, these are the full range cable that we can find in AC technology. So AC technology, the two on the left are land cable solutions, the four on the right are submarine cable solutions. You see that there is EPR technology for low voltage up to, or medium voltage up to 72 kV. Three-core technology, a state-of-the-art technology, is 245 kV, three-core conductor, huge cables. Single-core conductors in XLP, 420 kV. Over this voltage, we have to go with oil-filled cables. In terms of DC, we have two different technologies. Again, extruded technologies, plastic insulated, XLPE cables, able to work until 600 kV, plus minus 600 kV. P-laser technology is an in-house developed technology which is having a very special performance, able to work, operate at 90 degrees. So this is allowing a transmission over 3 gigawatt per a bipole. Mass impregnated cables, or PPL, mass impregnated polypropylene laminated cables, are able to operate even at higher transmission voltage and able to transmit more power. So just this slide, just to summarize what we have said. Mass impregnated cables can only operate at 55 degrees, while this P-laser is able to operate at 90 degrees. This means a saving, because the same cable can transmit more power, or to a same target of power, we can use a smaller conductor. Another very important advantage is that it can work for LCC transmission converter stations or BSC transmission converter stations. So this is converting this product in a very, very efficient and nice product. All these have been duly type tested, and we have all the complete protocols showing that the industry is in fact ahead of the market requirements. There is no existing project still at 6 kV with extruded cables. Again, these PPL, polypropylene laminated cables, are able to operate already at 700 kV. This allows a huge power transmission for each bipole. Another focus of attention is following the trend of the market. The trend of the market is having longer connections, which the DC technology can allow, is having more powerful connections, so this is why we are increasing the voltage, but having also deeper deep sea, deeper water depth connections. So in this area, we are focused on developing new alternative solutions, new installation means, new installation chips, just to be able to carry out projects that some few years ago were not even existing, and now clients, operators are considering the possibility of execution. Let me show which is our reference list, our business card, how we appear in front of the clients. This is just reference list in the industry, in DC extruded cables, present all over the world. In AC, as we have said, some of the state-of-the-art technology, this project in Çanakkale, intercontinental from Europe to Asia in the Dardanelles Strait in Turkey, It's a 400 kV cable, two circuits connecting the two continents. On your right, these three-core 220 kV cables, more than 100 kilometer length for the 50 hertz, the operator in Germany. These three cable routes in parallel, reaching nearly 100 kilometers in the Baltic Sea. This project, Western Link, this is called somehow the record of the record of the projects. Record in terms of 600 kV, the largest ever voltage grade for a transmission project. Record in terms of power transmission, 2.2 in continuous operation, 2.2 gigawatt. And not record in terms of length, but also very remarkable 422 kilometers. Another bunch of projects in the North Sea, offshore wind farm clusters, which have these connections from more than 100 kilometers and 100 kilometers in the sea, and also close to 50 kilometers in the ground, in land. We are having already installed and already in operation more than 2,000 kilometers of HVDC cables, extruded, basically 320 kilovolt. Another project of the record. This is one record in terms of water depth. This was the SAPEI, Sardinia Peninsula Italiana, 1,650 meters water depth. A real challenge in terms of cable design, in terms of installation means, and the trade-off between these two constraints. We have seen also this project in several of the several presentations of my previous speakers. This is the France, Spain, interconnection in DC, 320 kilovolt, land cable, galleries, huge drums, huge logistic requirements, and successfully completed. Another project which is ongoing is the Italy-France, still under construction. A lot of civil works, viaducts, and very complicated logistics again. Last but not least, this another ongoing project in the tunnel between UK and France, with another very challenging project in terms of availability of the working area, in terms of cable design, jointing resources, fire performance of the cable. So again, a huge challenge in terms of cable design and in terms of project execution. This is all from my side, but I want to share with you one thought that I believe we can share, many of us, that I am very proud of being part of a company, as you may be, of an organization which is pushing for a better world, which is contributing to a greener, a cleaner world for us, for our children, generations, and definitely our own existence. Thank you.